I will start with introducing actually what's all about the traffic data and the traffic flow information that is available, and then produce the Google traffic maps and the capacity of this sort of data, and then try to talk about the rainfall impact on the traffic itself and how it's used previously in the literature. Then I'll discuss the study area and the methodology that I followed in this research and the applications. And I have the applications here, and then conclude and try to discuss also the extension of this research. So, as you know, the traffic information that it's mainly collected through many ways, and it can be the most common way is the manual, using the videos and the sensors, and this kind of hardware equipment can be labor intense and also time consuming, which is side it's costly. While we have some kind of alternatives, usually people using the closed circuit TVs, the CCTV, which is can be affordable option. However, here we are talking about limitation in scale. And then we can also see now it's become very common to have the traffic video processing systems, which is using the deep learning and machine learning to detect the vehicles and tracking the traffic flow, which is also kind of installing these systems can be costly. And again, it's a scale limitation. Some researchers try to go beyond this and try to use intelligent traffic information along specific sections of the roads. And this is, it can be local studies, which is focused on specific segments, and again, scale issues. More or less, some authors also use the UAV, also focusing on road safety applications and traffic on the highways, and it needs also post-processing, and also it's used specifically for a short period within just the time of the flight. The last common option is using the GPS, which is mounted on the vehicles, and this kind of applications it needs large number of cars and vehicles that you need to mount the GPS to understand and give you at least an understanding of the traffic flow. This is an example of the deep learning and machine learning image processing, which is, as we mentioned, that it can be scale independent, with it's also with the cost. We have a look here. Actually, these photographs I took during my PhD research. So it's back to 2014, which is mainly in Malaysia. I don't know why the caption is not visible. As you see here, actually, landslide usually happen in remote areas where you have like a complex geomorphological features. However, sometimes it might happen in the city centers. So in Kuala Lumpur, we had two rain seasons, so we can expect like landslide happen along the year, which usually occur when within a very crowded areas. So if you see here, there's landslides, they cover a huge amount of volume of the traffic in the picture D, while in some events happen during the night. So looking at these pictures and trying to get some kind of research behind it. So first of all, when we see there are cars and landslide, we can think about the risk quantification here, because we have some objects under the direct risk. But on the other hand, which roads that we focus on? Because in Malaysia, we have a lot of research that did susceptibility mapping. However, hazard map with the frequent of the occurrence less common, but it's well known that where we have this kind of events. So since that time, we try to think about how to try to get the quantity of these cars which passing through these roads, and at the same time, can we use the cars itself as a proxy when we have like traffic at night, or to understand there is something can be landslide. Here we have a study that in 2020 it tried also to collect some data from Hong Kong and try to understand the impact of the rainfall condition on the traffic itself. So as you see in the figure, in the plot A and B, the authors try to list different type of cars, and also on the plot B, put also different like pictures of people also, and try to understand which category that it's more affected with the landslide itself, and then try to get the probability of this kind of failure with the annual exposure to rainfall. And another work that focus on the flooded area. So again, here I'm giving these examples to focus on the data itself, not on the application made. So as you see here, you have also a limited coverage of points, which is just intersections in the study areas. And the authors try to simulate this kind of traffics and understand the impact of the urban flooding on the traffic congestion during the rainy days. So as quickly we had a look on this kind of examples of using the traffic data, we agree that most of these research using limited sort of data on specific sections, which is in the landslide. It's a big problem because landslide usually you have a medium scale coverage. So unless you want to study specific road, that can be possible. So this came the idea of trying to use the Google Maps. So Google Maps actually offer a very dense and very huge amount of data, which is considered web resources, and the APIs that is available. It can really enrich the research in a positive direction. As you see on the left side, this is kind of services offered by Google, which one of them is distance matrix service, which is the one that related to the travel time of the vehicle. However, we talk about the accessibility and utility. So for the Google traffic maps, it's widely accessible and useful, but doesn't qualify as open data, because open data, it needs to be freely available, modifiable, restrictable, distributable without restriction, which is not the issue with the Google traffic map. So you cannot download it I say download in a term of a vector data or a numeric. Also, for the restriction of the use, you need always to understand how the data that is collected and at the same time strictly keep it as it is. You shouldn't edit even the image itself, giving the Google copyrights. Also, kind of the APIs that they are offering. The API, as you can see here, it's origin destination, which is in our case, if you want to monitor just one segment of the road, it's possible. But if you go for the entire network, it's a massive amount of work. Okay, so we'll jump to the research that we did here. So this research, the objective is to develop a tool set for real-time extraction of the traffic delay, which is we will deliver a sort of output, which is on firstly is a traffic pattern stored in SQL format, like table data. It can be ready for post-processing, and also kind of the maps of the daily average traffic delay, spatial temporal traffic flow, rainfall intensity traffic for relationship assessment. So in this research, actually, we choose two places, which is one of them is the city center of Perugia in Italy, and we have three types of roads. So via Fassani, it's one way, and Mari Angeloni, it's a two-way road, and also via Sette Settembre, it was also two ways. And then we had also another way, which is around the Como Lake. These kind of roads, we choose the B because Como Lake is susceptible to landslide. While the city center, it was trying to understand the traffic relationship with the products, because it was within our institute area, so it was easy to access to check what happened, why there is a red, why there is an obstruction in the road. The methodology here, quickly, without further detail, it kind of multi-phase analysis. So we have multi-phases here. So in multi-phases, which is this research, we try to test the unified procedure. So here I have like first phase one is to define the study area and use the OCM, the OpenStreetMaps, as a background for the spectrum data, because OCM is downloadable. And then I do the segmentation, and we try to understand the segmentation. I mean, like how to decide the pixel size for the analysis. So each segment is considered to be one unit of measure. And phase two, it's the main body of the code, which is, first of all, we connect this code into the Linux server, define the libraries, and then based on the bash code, we take the result and we create a database, and then in the real time, the extraction code will send the tabular data to the database, and then using the post-GIS, we produce the maps. And then we have also the capacity of the SQL queries to understand different kind of outputs. Then I did also the validation. So if you see the validation, also we run with saturation. So if you see the colors represent the traffic type, green is a flow, yellow is a little bit slower, and red until we have the dark, that means stop. So if you see here that the two, for each color, we have two data sets. One is the one that the extracted, and one is the actual. And you see the saturation in each map, it's almost similar. So the validation was quite good. Actually, we are not validating the data, we're validating the Google data. So if Google is correct, we are correct, but if Google is not correct, we have no clue. So we tested actually three applications. So first of all, it's to collect the data itself and put it in a meaningful way. So you see here that on the plot A, the maps represent the hourly data. This is one of the user preferences. So if you want to have hourly, to collect the data hourly, so we put it hourly here for 24 hours. And this is also for the entire city center. On the right side, it's the accumulated speed with the time, or let's say the aggregated speed. So as you see here, maybe you might ask, you don't have speed, how you get the speed? You have the delay. But here also we come up with the kind of assumption that consider the green is the maximum speed that allowed. So if it's 40 kilometers per hour, we consider that green is 40, because nobody assumed to drive more than the speed limit, let's say. Yeah, just we put assumption. Yeah, I mean, it kind of to just try to have something with the numerical here. Otherwise, quantitative answers don't want to be nice to plot. So as you see here, the different roads, they have some kind of relationship. Bassani, because it has no traffic light, it's one way, it's also a little bit out of the area, so you can see the behavior different from others. There are two ways, and you can start to see within 8 in the morning, when people go to work, you can start to have delay. the y-axis showing the kilometer. So slower, and then start to fluctuate because people during lunchtime going, and then you have the flow after 5 or after 7, people start to drive with a comfortable speed. And then we came back to second application. And here, what I was thinking that we have a real-time early monitoring system in the institute. So I was thinking also to bring a proxy of using the cars itself to have like a supported decision. So here we give a query saying that I want to find the cars or the traffic delay within specific hours, which is last for more than 1 hour. Because if it's, let's say, an accident within an hour, it can be easy. I mean, you can call the municipality, the police, they can. But if there's something lasts more than 1, 3, 4 hours, that's mean there's a real flow. So this is, again, it's a query. You can do whatever. Here, we are just testing different capacity of our products. So we did this and we have specific results. Then I went back and the data that I collected, because also I am storing those images up to the end of the analysis. Then I deleted because of the policy of Google. And I validated, and we saw, yes, we are quite well extracted those red and dark colors. So it's like the post-processing to go and find what's there. So this kind of data is coming hourly. So let's say we are sitting here and we get this kind of log. Then we can, within the same hour, we can try to find what is happening there, right? Rather than wait for any reports coming from the government after 1 or 2 days. The third application, also we try to understand the traffic relationship with the rain. Most of the literature saying there is no direct impact on the rainfall itself, unless you have really congested traffic. So in here, I took those 4 roads, and on the y-axis, I plot the delay itself. So you have green, yellow, and red. So and the y-axis and the x-axis, the time from 0 to 24. And the different colors, the color of the red showing the dry days. Unfortunately, this research done within summer time. Let's say there is not much rainfall, but we have to do it because we need to. I mean, I was almost the end of my contract there, so I was trying to push this research. So we did like 4 months of data with a slight amount of rain. So the blue colors here, it's reflect the intensity of the rainfall. So if you see dark colors, so you have like between 26 or more millimeter of rainfall, and the rainfall data is a radar data that's collected for the resolution is a bit I think 1 or 2 kilometer. So one area or one city center we have just one image. So it's a little bit coarse data, and we can see some kind of relationship when the dark blue appears here. We have delay in the traffic, but when we have no traffic or like easy-going traffic, even this rain, it won't do any kind of delay. Like as you see at the end of Albany Como, if you see that there are some dark colors, but still the green are the cars going easy. So to sum up, yet there is no open source tool that provide numeric data from Google traffic, specifically for a research purpose. So this tool can collect traffic data, integrate analysis, make queries, not only for the rainfall, but can be for air quality, environmental factors, and also it will give us deep insight in the traffic pattern with the selected influencing factors. For instance, you can try this kind of query. Find the delay, the degree of the delay, severe, high, moderate, low, for unusual, or unusual delays, that you can put any a statistical threshold on the specific roads within specific amount of time. Okay, so all of this kind of queries within a specific resolution also is possible. So for extension, I would like to we collect actually further information about the car itself, facilities, cars count, and also we extend the period of the collection. So if we have like 2 years of data, that we can see also the return of kind of the observation, let's say, and then we can have some robust correlation with which that saying this was accident, this was a landslide or severe storms, and also kind of supportive data like the rain gauges, police accidents, and insurance reports. Thank you very much.